Math 2414, representing functions as power series, video 4, visualization of the second example. As soon as I ended the previous video, I remembered that I wanted to give you the graphical interpretation of saying that this power series, converges to this on the interval -2 is less than x is less than 2. And if you're watching this video and not the previous one and wonder where all this came from, go back and watch the previous video, video 3 in the series. But I wanted to just give you a quick visual that the series on the right does converge to the function on the left by going back into Desmos. So let's do that. What I've got set up here is I've got the graph of the function f of x equals 1 over x plus 2. It's got the vertical asymptote and horizontal asymptote you would expect. I've got a graph of the partial sums going from 0 to k of -1 to the n over 2 to the n plus 1 times x to the n. And I've got vertical lines set up at -2 and 2 because convergence is supposed to happen in that interval. So let's turn on all the graphs. And right now I've got the upper limit for the sum starting at 0, evident by looking down here where it says k equals 0. We're going to take it all the way up to 25. And what I want you to do when I animate it is watch the blue graph. It will start fluctuating, but the longer the animation goes, the closer it's going to get to the red graph between the purple lines. In fact, let's zoom in just a little bit. There we go. All right, watch the blue graph. Right now it's at 1, 2, 3, 4. Let me pause it. You can already tell that we're getting some pretty tight convergence in the middle, but not towards the ends of the interval of convergence. As we raise the power on our polynomial, our partial sum, right now we're at a 10th power, going all the way up to x to the 10th. And if you notice, we've got much tighter convergence in the middle. We're still deviating from the ends. But to get closer approximation on the extreme parts of the interval, you have to use a higher and higher power. Let's take it all the way up to 25 and we'll speed it up just a little bit. There we go. And there we are at 25. And you notice by the time we get to 25, over here on the right end of the interval, we're still losing off towards the end, but we're a lot tighter than we used to be. And over here on the left end of the interval, we do have a little bit of divergence there, but that's because we only went out to the 25th degree. If we went all the way to 100, well, let's just do it. I'll just go up here and put 100 where the k is. Maybe. There we go. I think it's calculated it. No. I turned it off. Let's let it get caught up. I'll wait for it to turn off the graph. It shouldn't take too long now. There we go. Now let's turn it on and let's see how close it is to the portion of the red graph between the purple vertical lines. And we got very tight convergence on both ends. You can see it diverges a little bit here, but we have to zoom in pretty close. This is 1.9. So we're getting pretty tight convergence where we were expecting it. And again, it's graphing it really slow. It takes a long time to graph a 100th degree polynomial. Not forever, but there we go. All right, so I just wanted to give you the quick visual that we can represent the rational function 1 over x plus 2 with that series and get a closer approximation over the interval of convergence, which in this case was between -2 and 2, by simply letting the power, the upper limit of the sum, go higher and higher and higher.